Hello everyone, welcome to today's lecture. In our today's lecture, we are going to start our chapter number 5, which is a concept description and association rule mining. So let's start. These are the concepts that we'll cover in our chapter number 5, which is a concept description, data generalization, summarization, attribute relevance, association rule mining. And in the association rule mining, the method is market basket analysis. We'll learn an algorithm for finding a frequent item set, and that algorithm is a priori algorithm. And we'll also learn the improved a priori and incremental a priori algorithm in this chapter. And at last we'll learn what is the association rule mining and the concept of a rule mining. So that are the content that we'll learn in this chapter. So let's start with the first concept, that what is a concept description. So from data analysis point of view, data mining can be classified into the two categories: descriptive mining and the predictive mining. A descriptive mining means it describes the data set in a concise and summative manner and present interesting general properties of data. So a descriptive analytics will help an organization to know what happened in the past. It would give you the past analytics using the data that are stored. For example, it is necessary to know the past events that helps them to make a decision based on the statistics using historical data. So for example, if you might want to know how much money you lost due to a fraud and many more, so that can be done with the descriptive mining. The second is a predictive mining. So it analyzes the data to construct one or a set of models and attempts to predict the behavior of new data sets. So in a predictive analytics will help an organization to know what might happen next. It predicts futures based on a present data available. It will analyze the data and provide statements that have not happened yet, and it make all kinds of predictions that you want to know, and all predictions are probabilistics in nature. So based on the current data, you are predicting the futures, so that can be done with the predictive mining. So this is how the data mining is differentiated with the descriptive mining and the predictive mining. Now the next is what is a concept description. So a data description may provide an overall pictures of class of data or differentiate it from a set of comparative classes. Such a descriptive data mining is called the concept descriptions and forms an important component of data mining. So here it is said that a description or a data description provides an overall picture of the class of the data. Suppose we have a data sets and we have some description about that data set. So based on that description, we can say that this data set we can assume that this data set contains these types of attributes. So if we have a description of each and every database, so it is very helpful while we are differentiating the data sets based on their attributes. So such descriptive data mining is called the concept description and forms an important component in the data mining. Now the simplest kinds of descriptive data mining is called the concept description. The exact definition is the concept of the concept description is the simplest kinds of descriptive data mining is called the concept description. Now we all know what is a descriptive mining. It describes the data sets in a concise and summative manners. So a concept usually refers to the collection of data such as a frequent buyers, graduate students, and so on. We have a collection of data. Yes, so that collection of data are called the concept. And if we have the description about a description about that data, collection of data, then it becomes the concept descriptions. As data mining task, concept description is not a simple enumeration of data. Instead, concept description generates a description for characterization and comparison of data. So it is sometimes called a class description when concept to be described refers to a class of the object. If the description is about concept or about the collection of data, then it becomes the concept description. And if it is describes a class or the object of the data set, then it becomes the class description. Now it has mean two terms, characterization and comparison. First is a characterization. It provides a concise summarization of the given collection of data. So that is called the characterization, or that can be done with the characterization. So if we have a large amounts of data and we summarize the data into a small chunk, then it can be done with the characterization. And if next is a comparison, it provides a descriptions comparing two or more collection of data. Suppose if we want an cancer patient's data sets. So here the cancer patient data set is the concept, and we have multiple data sets of the cancer patients. So here we are comparing two data sets, so that comparison is done with the comparison techniques. So it is called, so that can be done with the comparison. So by comparing two data set, we are more able to choose one relevant data set. So that is why comparison has been done on the data sets. Now the next is data generalization and summarization. So a data set usually stores a large amounts of data in a great details. However, users often like to use a set of summarized data in a concise and descriptive terms. Yes, if you want a new data set and someone provides you a large data set to you, so to understand this data set is a difficult task. To fetch out the attributes, properties of data set is also a very difficult task for us. So everyone wants a summarized data in a concise and descriptive terms, so that we can easily get the knowledge about that terms, the data sets. So a data and object in a database. So data and object in a database contains a detailed information at a primitive concept level. Yes, each and every database has a detailed information. For example, the item relation in a sales database may contain an attribute describing a low-level item information, such as item ID, name, brand, category, supplier, place made, price, etc. So these items may contain a very detailed information. It is useful to able to summarize a large set of data and present it at a high conceptual level. So the data generalization and summarization is used to summarize the data such that, or generalize the data in such that low level data will converted into the high level conceptual data. So for example, summarizing a large set of items relating to a Christmas season sales provides a general description of data, which can be very useful are helpful for sales and marketing managers. So if we have a data of sales, so at the Christmas time, if we generalize the data or we summarize the data to a smaller format and will provide that data to the managers or the salesperson, so they can able to create a sales, or they can able to create a new offers on that time periods. So that may be useful in that type of situation also. So that is why it is important. So this types of generalization, this type of summarization can be done with the help of data generalization techniques. So this requires an important functionality called the data generalization. So let's understand what is the data generalization. A process that abstracts a large set of task relevant data in a database from a low conceptual level to the higher ones. Yes, to converting a low level data into the higher level of data are called the data generalization. So suppose, let's take an example here. Suppose we have a data of cities of each and every country. Yes, so that cities data is too detailed. Yes, it contains names of each and every city of each and every state and each and every country. So we are generalizing that cities data into the countries data. So our data set also reduced and it contains the high levels of data. Yes, we'll divide that cities into the countries. So here our data is become the higher level. Data is converted into the higher levels. So that process of converting lower level data to the high level data is called the data generalization. Data generalization is a summarization of general features of objects in a target class and produce what is called the characteristic rules. The data relevant to the user specified class are normally retrieved by a database query and run through the summarization module to extract the essence of data at a different levels of abstraction. Yes. So generalization of data of the relevant data to a user specified class are retrieved by the queries. We are writes a query in such a way that only that data is retrieved that user wants, or you can use a summarization module to extract that data on the different levels. So it has so for example, one may wants to characterize the our video store customers who regularly rent more than 30 movie years. So that can be done with the query also, and if we want, we can also provide a generalization module on that. So with the concept hierarchies on the attribute describing the target class, the attribute oriented induction method can be used. So that is about the generalization module. We can apply the generalization module as attribute oriented will apply the attribute oriented induction method on that module, so we can fetch that relevant data. So for example, to carry out the data, for example, to carry out data summarization, we can use these methods. So that is about the data generalizations. Now not that with a data cube containing a summarization of data, simple OLAP operation fit the purpose of data characterization. Now we know what is a data characterization. So data characterization provides a concise summarization of the given collection of data. So here it said that in OLAP cube, the data stored is the summarized data. Here the data cube contains a summarization of the data. So the OLAP operations are used for data characterization purpose. Now the next and the approaches for that is a data cube approach, which is a OLAP approach, and the second is a attribute oriented induction approach. Yes. So in the data cube approach, it can be considered as a data warehouse based or a pre-computation oriented or a materialized view approach. So with that approach, we can compute over the OLAP cubes and create the results in a data cubes. It also performs an offline aggregation before the OLAP or data mining query is submitted for processing. And the strength of this approach is it is an efficient and implementation of data it is an efficient implementation of data generalization. Also the roll up and drill down operation is also very important. We can say that it is useful for that generalization purpose. The second approach is an attribute oriented induction approach. So it can be performed in two ways, by attribute removal and attribute generalization. So in the attribute removal is based on if there is no generalization operator on the attribute, then remove that attributes and it's a higher level concept. And second is if it's a higher level concept are expressed in terms of other attributes in the relation, then remove the attributes from the initial working relations. So this is how we can remove the attribute. And the second is attribute generalization. So it is a subjective to how high the attribute is generalized. While attribute oriented generalization, a balance should be maintained so that it should not be too high or too low generalization. So the control of this process is called the attribute generalization control. So this is how attribute oriented induction approaches work. So we can say that in the data cube approach, we'll use the roll up and roll down operations, OLAP operations for generalization purpose, and in an attribute oriented induction approach, we are using the attributes. So we'll remove such attributes from the data sets which is not in used or not in relevance, and also we'll generalize each and every attributes with the help of we'll generalize the attributes in the same manner, so that the balance should be maintained. So that is all about data generalization. So in today's lecture we'll learn what is a concept description. In this we'll learn descriptive mining, predictive mining, and also the two other terms is characterization and comparison. Next we'll learn that what is a generalization and summarization. So dataset contains a large amounts of data, so everyone wants data in summarized and concise format. So for that, the functionality used is called the generalization. So the generalization is the process of converting low level detailed data into the higher level data, the summarized data. And the approaches for that is a data cube approach and attribute oriented induction approach. So that's it about the today's lecture. Thank you so much for listening. Have a great day.